On example 414, they're giving us a beat frequency produced by a tuning fork and a guitar string played together. The tuning fork is a 440 hertz tuning fork, and you play that and guitar string at the same time and you get a beat frequency of 4 hertz. Now that means that the guitar string is 4 hertz away from 440, except I don't know if it's 440, if it's 4 above or if it's 4 below 440. So it's either 436 hertz or it's 444 hertz. Either one of those would give you a 4 hertz beat frequency. So these are our two possibilities for the initial frequency. Now you're going to tighten the guitar string. And they told you that increases the frequency, but you knew that anyway, because tightening the guitar string will make the wave speed higher. Remember that the wave speed on a string is the tension divided by the mass per unit length. Now if I make the string tension higher, that's going to make the wave speed higher. That's not going to change the wavelength. The wavelength is predetermined based on the length of the string, and so I'm going to get a bigger frequency. So now I look ahead and I see that as a result the beat frequency decreases to 3 hertz. Now I know a little bit about this, and so do you. And so we know that we've changed the frequency by 1 hertz. And so if I increase the tension on both of these strings, this one might go to 437 and this one might go to 445. And only one of those is giving me 3 beats with the 440 hertz tuning fork. And it's the 437. 445, 444, that's not going to work, it turns out. And so it turns out that the 436 hertz was the initial frequency of this guitar string, and now the final frequency is 437 hertz. Now it says in number 7, suppose the initial beat frequency is 4 hertz and tightening the string causes the beat frequency to increase steadily to 6 hertz. What are the initial and final frequencies of the guitar string in this case? And so my possibilities to start are 4 hertz, so 444 or 436 hertz. They're both 4 away from 440, and now we're going to tighten the string again, and that's going to make the frequency higher, and we're going to tighten it, and we're going to get now a difference of 6 hertz. Well, tightening this one could make it 446. Tightening this one could make it 438. You might say, how do you know to go by 2? Well, I know the difference between 440 and whatever I have in the second part is going to be 6, and so that's where I'm jumping by 2. I just know I could get a lot of different things if I just tighten the string. Regardless, now looking at these two final frequencies, only one of those is going to give you a 6 hertz beat frequency, and that's going to be this 446 hertz. So that's going to be my final, and my 440 hertz is my initial, not these. In number 8, you have 3 tuning forks, 252, 256, and 259 hertz. They say, what possible beat frequencies could you get here? Well, you're gonna choose them 2 at a time, and so there's 3 combinations of 2 here. So I could take the 252 and the 256, and I could play those together, and I could get 4 hertz. I could take the 252 and the 259, and I could play those together, and I could get 7 hertz. And I could take the 256 and the 259, and I could play those together, and I could get 3 hertz. It says 2 musicians are comparing their clarinets. First clarinet produces a tone that is known to be 441. When the 2 clarinets are played together, they produce 8 beats every 2 seconds. So 8 beats every 2 seconds, that's giving me a beat frequency of 4 hertz, 4 beats per second. It says if the second clarinet produces a higher pitched tone than the first clarinet, what's the second clarinet's frequency? I need something that's not just 4 away from 441, but higher than 441. So I'm going to take my 441 and I'm going to add on my 4 hertz, and I'm going to get 445 hertz. On number 17, it says two tuning forks have frequencies of 278 and 292 hertz. What's the beat frequency? We know that the beat frequency is frequency 1 minus frequency 2, absolute value behind those. Take one of them and put it where you like, put the other one in the other slot, and I'm going to get 14 hertz. Number 18 has 4 pairs of tuning forks, and they want us to rank them in terms of what beat frequency will you get whenever you play them together. And so we know that the beat frequency is just the absolute value of the difference between their two frequencies. And so if I calculate the beat frequencies down here, I get a beat frequency of 4 hertz, that's the difference, 10 hertz, that's the difference, 1 hertz, that's the difference, and 6 hertz, that's the difference. So putting those in order, I have C is the smallest, and then A, and then D, and B is the biggest.